Hey class, we're going to start chapter 2, which is all about descriptive statistics, the numbers behind the data. So things like mean, median, mode, ways to display data, graphs, that kind of thing. Right? So basically, if you start with raw data, how do you organize it? How do you present it? So the first thing we'll look at is 2.1, which is on frequency distributions. This first example gives an example of a frequency distribution, and so we can look at what kinds of information that you get from it. Right, so this first problem is the points scored by the winning teams in the first 52 NFL Super Bowls. So the way I would read a frequency distribution, right, it's arranged into classes. So that first one, 5 teams won the Super Bowl by scoring between 14 and 19 points. And it's the same for each class, right? So I go all the way down. There are 2 teams that had between 50 and 55 points and won the game. Okay, so some information just to start getting some vocabulary going. How many classes are there? Well, that's just how many rows we have. So it looks like there are 7. Lower class limits, those are just the lowest number in each class. So those 7 values, starting with the 14, right? 14 is a low one, 20, 26, right? All the lowest numbers for each class. Right? And then similar, upper class limits is just the highest number in each class. And there you go. So those are called lower and upper class limits. Class width, that's how many values are in each class. And just think about whole numbers only here. So careful, because if you look at that first class, the difference between 19 and 14 is 5, right? 19 minus 14 equals 5. But actually, the number of whole numbers in that class is 1 more than that, because you're including both endpoints. So if you count them, 14, 15, 16, 17, 18, 19, that's a total of 6 numbers. So the class width is 6. Another way to do that is you can subtract 2 consecutive lower or upper class limits, right? So if you took 14 minus 20, for example, right, that's equal to 6. And that's true for any 2 consecutive values in the LCLs or UCLs. Right, 55 minus 49, it's 6. Okay, so that's another way to get that class width. For number 5, the sum of the frequencies, there's a symbol for sum. So anytime you see sigma, think of adding, right? So sum of the frequencies, you're just adding up all these numbers, right? 5 plus 12, etc. Or we already know what that is because it's given right here, right? There should be 52 total teams. I can verify, though, if I add up all these numbers, that's equal to 52. Okay, so that's a little intro for distributions. Now let's generate our own. So what we're going to be doing mostly is, given a raw set of data, organize your own distribution. And so here are some steps for constructing one with that raw data. So I'll refer back to these as we go through an example. So on the next page, 18, we have a list of raw data, right? These are exams for a math class. It's not organized in any way, just a random array of numbers, and we're going to organize it into a distribution. I already put that at the bottom of the page, just leaving some room to work there, but those first 2 columns, the class and frequency, that's what we've just been dealing with. Notice you can have some other things as well, midpoints, relative cumulative frequency. So we'll get to those as well, but let's get to it. Okay, so the first thing you got to do is find the range. And the range has its own little formula here. It's the maximum minus the minimum. So range, sorry, sometimes my pen just stops working. I probably need to get a new one of these stylus things. All right, now we just gotta hunt for those things. So the max, looks like I see a 97, that's the biggest. And the minimum, I know there's a 50, and there's nothing lower, right? So there's the biggest minus the smallest. 47. There's your range. Okay, now what you're going to use that next is to find the class width. So that would be the second thing. Class width, notice, uses the range. Class width is the range divided by the number of classes. Now, how many classes you use, if you're in MyLab, it'll just tell you. But if you're actually doing some research, you just decide on the number of classes that seem appropriate for the data that you have. But for this one, we're going to do 5 classes. So the class width is 47 divided by 5. And that's, calculate that out with our calculator, 9.4. That sound good? Nice to have a calculator handy for this class. Okay, so, but that's not quite the class width yet, because I'm sorry I keep scrolling all over the place, but notice an important thing is that you're always going to round up, right, to the nearest whole number. Always round that class width up to the nearest whole number. Even though your normal rounding rules here, 9.4 would round to 9, right? It's closer to 9 than 10, but it doesn't matter. Any decimal gets rounded up. So the class width is 10. The reason for that is if you round down, you're going to end up with some numbers at the end that don't fit into any classes. So this is ensuring that you have large enough widths in your classes to get all those numbers in a category. Okay, what do we do next? So once we've done those 2 steps, next we're going to find the lower class limits. Right? The first lowest class limit, here's the key, the first lowest class limit is just that minimum data value in your data set. Okay, and again, here's where there's some gray areas, right? If you're actually doing this in the real world, you might set your own minimum data value as not that, as a different number than the LCL. So, but to get things right in MyLab, always use your first LCL as the min data value. It's a good place to start. Okay, and then the other LCLs, you're just going to add the class width. Like we saw before, we know the difference between LCLs is the class width. So I'm going to start with the minimum so the LCLs. The minimum, remember, was 50. So that's my first one. Right? And then I'm just adding the class width. Add 10. Add 10. Add 10. Add 10. Until I get 5 of them because I want 5 classes. These are all those lower class limits. Right? Okay. How about upper class limits? So for number 4, upper class limits, the first one is 1 less than the lower class limit of the second class. All right. That makes sense, right? I mean, if you think about the ranges here, the UCLs, right? My first class is going to go from 50, but it's going to stop just short of 60, right? So it's going to be 50 to 59, right? 1 less than that second LCL. Right? And then same pattern. Right? Those are all your UCLs, okay? So now I can start generating my classes. I can start filling in this table, right? Because I know my first class goes from 50 to 59. So it's that range, 60 to 69, 70, 79, 80 to 89, and then 90 to 99, right? Now notice it goes all the way to 99. There is no data value, 99. We know that the largest was 97, but that doesn't matter, right? The key is all the data values are going to fit into a category, okay? Okay, so we got that. Next, we want to get the frequency, right? So I think that's what's next. Yeah, for number 5, find each class frequency. That's just a count. Count how many data values are in each class. Pen turned off again. Okay, so you're just, so for example, that first one, right, for this range of 50 to 59, look at your data and you're just going to find all of them that are in the 50s, right? So maybe I'll erase that one, right? Because I got 150, right? And so do we see anything else that's in the 50s? And you might just cross them out as you go, right? There's a 50, there's a 50, there's a 50, a 50, there's a 50, there's that one, the smallest one, and I think that's all of them. So there's a total of 6 numbers that fit in that class. That will be the frequency of that class. So you see, it's not the total number of values that are between 50 and 59. There's 10 of those, right? It's how many are actually in your data set. 6 values from your data set that fit in that class. And you're gonna do that for each class. So that's the tedious part, because you got to kind of hunt for the numbers and count them up, and it's easy to miscount and etc. But if you want to verify these numbers, I won't bore you with doing all this counting in this video, but it does end up being that as the frequency, right? And then the total sum, if I add all those up, that's 41. And I would just, that's a good double check. I would just verify that there are 41 numbers here listed, so that I counted every one of them and I didn't double count any. Okay, and then there's the frequency. Okay, next column is midpoints. So that's just the middle of each class. So for example, between 50 and 59, where's the middle? Right? Now there's a formula way. Sometimes you can just eye it, right? But there is a formula. Each midpoint is kind of like an average of the lower and upper. So I can, like for that first one, I'll just do 1 for the calculation. Right? 50 plus 59 divided by 2. Right? So that would be 109 divided by 2, or 54.5. That would be an MP for the first class. Right? 54.5. Right? And you probably can just see that, right? It's 54.5 is right in the middle of 50 and 59. Now the cool thing about midpoints is they all differ by the class width again. So I could just keep adding that class width. That works, right? Just a pattern. So I really don't need that formula for all of them. Do the formula once, and then use your class width, add it, right? Or you usually can just eye that. Seems like it's a good little pattern there, and we're getting there with this frequency distribution. A lot goes into it. How about relative frequency? That's the next thing. So back up to my steps. Relative frequency. Ooh, look at that formula. All right. Basically, you're changing it into a percentage. It's the frequency divided by that sum of frequencies. And we knew the sum of frequencies was 41. So to get the relative frequency, just divide the frequency for the class divided by 41. All right, I could do that. So in other words, I'm running out of room, but I'll do 1 or 2 of them. This first relative frequency, the frequency is 6. All right, divide that by the sum of the frequencies, 41, and then you might have to do a little rounding. Let's just go 3 decimal places on this. And so that's about 0.146. Just use your normal rounding rules. Right, that's your, right, so if it's 5 or up, you're going to round up. 4 or lower, keep it the same, that kind of rounding rule. So 0.146 is that one. Okay, and then for each one, you're dividing by the 41. So the next one would be 4 divided by 41, 15 divided by 41, etc. Right? And if you do it correctly, these are the numbers that should work out. Okay, and then there's a way you can check this, because these are all basically percentages or proportions. That should all add up to 100% or 1, right? So if you add all this up as a double check, now we did do some rounding. I think this actually adds up to 1.001, okay, which is just a little off because of rounding, but you should always get 1.001 or maybe 0.999. Double check, make sure you didn't make any errors on relative frequency. All right, back up to our list. last thing is the cumulative frequency, number 8. Each cumulative frequency is the frequency of that class plus the frequency of all the previous classes. And that the value of the last cumulative frequency should be the total 41 in this case. Right? So in other words, the way this is generated, the first one just matches. Right? And then you're just accumulating the frequencies as you go. The next one, take the 6, and now you're going to add the 4 from the 60s. Right? Add the 4 to the 6. Which is 10. I must have messed that one up. Right? And then keep on with that pattern. Now you have a total of 10, 60s, and 50s. Now you're going to add the 70s. 10 plus 15, 25. 25 plus 9, 34. 34 plus 7, 41. And yep, that's the sum, so that's good. We did it. There's a complete frequency distribution. Okay, now you have, you've basically converted raw data into something that's a little more organized, has more information, has a breakdown of how that distribution looks as far as the spread of the data and how the class did. Looks like there was a lot in the 70s there, 15 students, with less in the 50s, 60s, a little bit more in the 80s and 90s, so maybe that's pretty good. Some more students did well than did worse than average. Okay, so the next step is going to be, now can we turn this into a visual graph? So a frequency histogram is what we'll call it. But I think that's a good point just to stop on this video, take a small breather. The next video is going to start on page 19. Okay, thanks for listening. You made it all the way through.